Hi, guys. Welcome to this session of numerical solutions. Now let's focus on analytical problems. Recall parallel combination of resistors. Each resistor has its terminals connected across the same 2 points in the circuit. The voltage across each resistor is the same. The total current divides among the individual resistors. Advantages of parallel combination. Independent functioning. In a parallel connection, each component, resistor, bulb, etc., has its own separate path for current. If one component fails or is removed, it doesn't necessarily affect the others. Brightness and voltage stability in parallel configuration. Components in a parallel circuit receive the same voltage across them. This means that devices, such as bulbs, will maintain their brightness even if additional bulbs are added or removed from the circuit. In parallel combination, the reciprocal of the equivalent resistance is the sum of the reciprocal of individual resistors. Total current is equal to the applied voltage divided by the equivalent resistance. The current in each of branch is calculated as when all resistors in parallel combination have same resistance. Then the equivalent resistance is resistance value divided by the number of resistors in the combination. Current in each branch is total current divided by number of resistors. Let's solve some analytical problems from previous question papers. Consider one single bulb connected as shown. The total current is equal to the current drawn by bulb B1. Now the second bulb B2 is connected in parallel as shown. The total current is equal to the sum of the current flowing through the bulbs B1 and B2. Now the third bulb B3 is connected in parallel as shown. The total current is equal to the sum of the current flowing through the bulbs B1, B2, and B3. The total current is decreased when bulb is removed or gets fused. A1, A2, A3, and A are ammeters connected in the circuit. B1, B2, and B3 are 3 identical bulbs. They all are connected to voltage source. As shown in figure, when the 3 bulb are working good and glowing, the current recorded in ammeter A is 6A. Answer following questions. A. Same amount of current will go through each bulb, and the value is 2A. True or false? Recall, in parallel combination, when R1 equals R2 equals R3 equals R, then I1 equals I2 equals I3 equals I/3. Since bulb are identical and connected in parallel same voltage, same current will flow through each bulb. Since the total current is 6A, individual current will be 2A. Question. B. If the bulb B3 is blown away, the bulb B1 and B2 will start glowing more. True or false? Recall, in parallel combination, each component, resistor, bulb, etc., has its own separate path for current. B. If the bulb B3 is blown away, the potential difference across other bulbs still remains same, so same current will flow, and they will glow as it is. No change. False. Question. C. What will happen to the entire ammeter reading if bulb B1 is blown away? When bulb B1 goes down, the current in that part becomes 0. So reading of ammeter A1 becomes 0. Reading of ammeter A2 will remain same, i.e. 2 ampere. Reading of ammeter A3 will remain same, i.e. 2 ampere. Reading of ammeter A will be equals 2 plus 2 is equal to 4 ampere. Question. The current shown in ammeter A remains same even any bulb goes down. True or false? As seen in case C, the reading of ammeter A will change. Hence answer is false. Recall, the total current is the sum of the individual current in each bulb. So when is blown away or switch off, its current will become 0, thereby decreasing total current. Next question. Reading of ammeter A1 is 1 ampere. Let R1 be the equivalent resistance across V1. The two 3 ohms resistors are in parallel. Therefore, R1 is 1.5 ohms. Voltage V1 is the voltage drop across R1. By Ohm's law, it calculated as V equals IR. The reading of V1 is 1.5 volt. Similarly, R2 is equivalent resistance of 3 ohm resistance combination of 3 resistors. Now R2 is 1 ohm. Reading of voltmeter V2 is 1 volt. Now, R3 has 4 3 ohm resistors in parallel. Hence R3 is 0.75 ohms. Total resistance is R1 plus R2 plus R3. Since R1, R2, and R3 are in series, so A1 equals A3 equals 1 ampere. Question. B. To find relationship between A2 and A3. Recall, when all resistors have same resistance value, then current in individual branch. It is calculated as total current divided by number of resistors. V1 already calculated. V1 is 1.5 volt. Total resistance is 3.25 ohms. Tip: use UBasic to solve such questions. Thank you for watching the video. For any such questions, contact us.